Hey, how we doing? Quick one. How do trains eat? They choo choo. Okay, here we go. We've talking about a topic here that's fairly broad. So I'm going to try and break it down into what I think are the essentials. We're talking about linear modeling. It just means that we're using straight line graphs in a bunch of different practical situations. Long story short, read the graph, answer the questions. Okay, or sometimes make the graph, read the graph, answer the questions. Now, I think there's three main types of questions that they'll ask. The first one is to kind of find this given that. So using the graph, they'll say something like this: find the height when the weight is 40 kilograms and find the weight when the height is 150 centimeters. So you can see here on my y-axis, I've got weight and in kilograms, and on my x-axis, I've got height in centimeters. A lot of the times when they ask for these ones here, just line it up. So find the height when the weight is 40. So my weight, whoops, I should go to where my weight is 40, sorry. And then line it up with the line. And you can see here, my height here is 80 centimeters. Okay. And if I go the other way around, find the weight when the height is 150 centimeters. So I go height 150, which is there. I line it up and I can see here approximately, if I've drawn this correctly, I would say roughly probably 75 to 78 kilograms. And again, sometimes when the graph is unclear, you have to make your best kind of guess. But can you see how all we're really doing is we're lining it up? So whenever you've got to find this given that, just find the corresponding X or Y value on the line, okay? Follow the line, that's your point. Okay, now the other type of question, I think this one's fairly straightforward, but the other type of question is a little bit more on understanding. And so they'll say something like, explain the gradient in its context, or maybe they won't even say, they'll say find the gradient or like explain what this means. And so let's just talk about this first. We remember that gradient means rise over run, or in other words, it's our slope. So if I'm talking about our M, I'm going to pick 2 points that I know. And I can see here that if I draw a little right angle triangle just here, there's my rise, there's my run. I can see that my run is 3. And then my rise here is 80. Okay, just kind of going off, not the squares, but the actual values that are on my axes. Okay, so in this case here, my gradient is rise, which is 80, over run, which is 3. Now, to explain the gradient in its context means we actually have to talk about the liters and kilometers. And so again, I'm not going to give a situation to this question because it could be a bunch of different things. This is just to give you an example. And what this really means is, okay, I'll say something like for every 3 liters, right? So for every 3 liters, it gets me 80 kilometers. Okay, so it could be talking about petrol, which is most likely what it's talking about. Maybe it could be how far you can run. Don't know. There may be different contexts, but essentially you just have to talk about the rise and the run and the relationship between the two, given your 2 units. Okay, so that's what I'd write. If it's an explain, you have to use some sort of words. Now, note here, I'm not writing an essay. I'm just saying very minimally, every 3 liters gets me 80 kilometers. That's my gradient. That's the gradient in its context. Okay, now the last one is explaining this concept called the y-intercept, which essentially is the plus c of your equation, or in other words, where it cuts the y-axis, and you can see that it's right here. So it's kind of at the 10. Now, again, keeping this fairly generic, let's talk about money and kilometers. We can change the examples. I'll show you what I mean. But when they ask you to explain the y-intercept, if it's at 0, that's kind of like the least interesting one, because that means, I don't know, it's a direct correlation. Remember, if we have a If it goes through the center, goes to the origin, it doesn't have a y-intercept, well, what we say here is, yeah, it's a direct proportion. However, if we kind of move away from that and we have a different y-intercept, you can see here that it actually means something. And so, for example, even if I had done 0 kilometers, let's say, for example, this is you're hiring a taxi. Even if the taxi has driven you 0 kilometers, you still have to pay $10. Okay, so sometimes what they'll say here is that $10, it's like that $10, it could be what we call a booking fee. So sometimes if you hire someone to do a job, even before they work on it or before they make anything for you, there's an upfront cost. Could be a booking fee. Sometimes if it's like taxis, we call that a flag for. And it's essentially, they're the same thing. It's a booking fee. We just call it different things. So yeah, that's probably the only thing to talk about. And it's this idea. And again, if it's explained, and you write something small phrase, even for 0 kilometers, you are charged $10. Okay, and then that's when you kind of say it's like it's probably a booking fee or it's probably a flag for. That's what that is. Okay. Hope that helps. The only way that you really get good at this is by completing many different types of questions. Whoops. With many different situations, with many different axes. And yeah, that's it. I'll catch you on the next one. All right. Bye.